Barium hydroxide is a strong base used in inorganic and organic reactions. Figure 2.1 shows the reaction scheme involving barium hydroxide. Okay, so we have started with the solid barium oxide dissolves in water forming barium hydroxide aqueous. On heating, in reaction 2, okay, it turns into barium carbonate and water, okay, and in reaction 3, A is formed. So in reaction 3, as ethanoic acid is added, so A must be barium ethanoate. And here, barium hydroxide must be reacted with any metal carbonate like group 1 carbonates because they are water soluble. Okay, we are getting only water. So it means that a carbon dioxide gas has been dissolved. Okay. State the variation in solubilities of group 2 hydroxides. You must know the trend that down the group, the hydroxide solubility increases. So it increases down the group. What is observed in reaction 1? So if we see reaction 1, it's a solid. So what happens that, and it's a group 1, group 2 solid, so group 2 compounds are white, right? So white solid disappears because if you see in reaction 1, we are getting only aqueous. Okay, so just a reactant for reaction 2. So what we have decided for a reaction 2, the reactant would be carbon dioxide. Then they ask you to identify A, and for A, we already worked it out. It's barium ethanoate, right? That this ethanoic acid, when reacts with the barium hydroxide, we are going to get barium ethanoate. Is this clear to all of you? Till here? Now, part 5, barium hydroxide is made by the reaction of barium with water. Write an equation for this reaction. Okay, so we know when a metal reacts with water, we will get a metal hydroxide and hydrogen. So barium, when reacts with water, we got barium hydroxide, BaOH twice. And along with this, hydrogen gas is released and it's aqueous. Here we got a liquid, here we got a solid. To balance the equation, we have to put a 2 over here. Is this clear to all of you? Now, part B. The mineral barytocalcite contains both barium carbonate and calcium carbonate. Both compound decompose on heating. Okay. State which compound decomposes first when barytocalcite is heated. Explain your answer. So if you recall, the thermal stabilities. So the thermal stabilities increases down the group, right? So, and if you look in the periodic table, you will find beryllium, magnesium, calcium, strontium, barium, radium. So see, barium is over here and calcium is top. So the one which is at the top have a compound relatively less thermally stable, and the compound which are bottom are more thermally stable. So the compound which decomposes first would be calcium carbonate because the calcium is above in the periodic table. Uh, and it is because the thermal stability of group 2 carbonates increases down the group. Is this clear to all of you? Yes, if any one of you has any confusion, please ask. Now, part 2. Construct an equation for the complete thermal decomposition of baryto calcite. The formula of baryto calcite is barium calcium carbonate. So see in it, there is a barium carbonate as well as calcium carbonate. So when we decompose any carbonate, we get a metal oxide and carbon dioxide, right? So there are two carbonates and they are both the metals are there. So we are going to get a barium oxide. We are going to get a calcium oxide and carbon dioxide. As there are two carbonates, so it would be 2 times CO2. Is this clear to all of you? Yes. Part C, barium hydroxide is used to hydrolyze organic compounds. Okay, yeah, it's an alkali, that's why. For alkaline hydrolysis. Figure 2.2 shows the reaction of B with barium hydroxide followed by acidification. Okay. Draw the structure of the organic products of the processes shown in figure 2.2. Okay. Okay. So if you see, there is a nitrile and there is a carbon dioxide. So let me open the structure. Here we got a carbon nitrogen triple bond, and here we got a C double bond O, and then CH3. So as a hydrolysis has been taking place, so it means it is going to break down from here and here. The organic product too would be this thing that O CH3, and here we got a H from the water. So we got a alcohol. And the if you look at the rest of the part, and see they have mentioned followed by acidification. That is the important thing, because they if the have added the acid in it, it means that we are getting a carboxylic acid. So both the carbons turns into carboxylic acid, and if acid would not be added, that's what you need to remember, because Fatma, they have seen hydrolyze. So you must recall the hydrolysis has been done by four type of a compounds. Nitrile undergo hydrolysis, esters undergo hydrolysis, amide undergo hydrolysis, and alkyl halide undergo hydrolysis. From those functional groups which are able to make these four compounds, from where the compound would be broken when the hydrolysis occur. So we got a carboxylic acid over here, and we got a carboxylic acid over here as well. Is this clear to all of you? And if they didn't mention this, then instead of this, we are going to add this thing over here. Like the we are going to barium over here. Okay. Now, question number 3. Potassium chlorate KClO3 is widely used as an oxidizing agent to make oxygen. Define oxidizing agent. So now they are asking you to define oxidizing agent. So we can write that it is a substance that oxidizes other substance. Substance that oxidizes other substance and itself get reduced. Yes, very good, Umar, but it's reduced itself. Okay. Now, B part. Potassium chlorate solid decomposes when heated. Manganese oxide MnO2 catalyzes the exothermic decomposition reaction. Okay. Complete and label the diagram 3.1 to show the effect of MnO2 on decomposition of KClO3. Okay, we know what catalysts do. Catalysts would lower the activation energy, right? So we are going to make one like this. Obviously, that is, uh, without MnO2, or you can write without catalyst. And then another one like this. And here I will mention that it's with MnO2 or with catalyst. Is this clear? Yes, any questions? Okay, now C part. When KClO3 is heated without a catalyst, KClO4 and KCl form. Explain why this reaction is described as a disproportionation reaction. Okay, so the disproportionation reaction is the one in which a single species being oxidized and reduced. And if you see here, it's a chlorine. Here, the oxidation number of chlorine is +5 because it's -2 times 3 and it's +1. And if you see, it becomes -4, 4 oxygen. So -2 times 4 makes it -8 and it's +1. So here the chlorine would be +7 and here the chlorine would be -1. So see, and so that's why this reaction is a disproportionation. Uh, it is because chlorine is both oxidized and reduced. Is this clear? B. Molten KClO3 reacts with a glucose. Okay, here we got the equation. KClO3 melts at 630 Kelvin. At this temperature, both carbon dioxide and water are gases. Okay. Use the ideal gas equation to calculate the volume in meter cube of 1 mole of a gas at 630 Kelvin and 1 exponent -5 exponent 5 pascals. Okay. Give your answer to 3 significant figures. So if we recall the expression, it is PV is equals to nRT. And we know if we have to find the number of, they have asked you to calculate the volume for 1 mole of a gas. Okay. So volume is equals to nRT over P, where the number of moles are going to be 1. R is in ideal gas constant. Its value is 8.31 times temperature. Temperature is always taken in Kelvin and they have provided you the temperature in Kelvin, right? So 630 and then divided by pressure. Pressure is always taken in pascals. So, and they have provided you the temperature in Pascal, oh, sorry, pressure in Pascal. So 1 exponent 5. Can anyone calculate the answer? And okay, so it's 0.0524 meter cube. Thank you, Shri. So we got the volume in meter cube. Now, 5 gram of glucose reacts completely with molten KClO3. Use your answer to D1. Calculate the total volume of gas released at 630 Kelvin and 1 exponent 5 pascals in this reaction. If you are unable to D1, okay, okay. So we have to calculate the total volume of gas. Okay. Now if you see over here, 1 mole of glucose releases 6 moles of carbon dioxide and 6 moles of water. And as they have told you that at 630 degrees Celsius, both are gases. So it means that 1 mole is releasing actual 12 moles of gases. 1 mole of glucose is releasing 12 moles of gases. Is this understandable to all of you? So if we can make a one relation or a ratio over here, that glucose versus gases. And from the balanced equation, we got it. 1 mole of glucose is releasing 12 moles of gases, right? And here it's a 5 gram. So from 5 gram, we can easily convert it into a moles. 5 gram of glucose means 5 divided by 180 because 180 is the MR of the glucose. Can anyone calculate the answer? Can anyone tell me the moles of gases? Okay, it's 0.0278. So these are the moles of gases, that is 0.0278 are the mole of a glucose, and how much volume moles of gas can be produced? So X is equals to 0.0278 times 12 divided by 1. So multiply 12 to get the moles of gases which are actually produced. Yes, can anyone tell me the answer, please? It's 0.333 moles. Thank you, Shri. So we know that 1 mole of a gas is occupying 0.0524 meter cube. And if the number of moles of gases are 0.333 moles, right? Then the volume of a gas must be X. Now calculate the X. 0.333 times 0.0524 divided by 1. See, from the balanced equation, as they have told you that at 630 Kelvin, both carbon dioxide and water are gases. So 6 moles of carbon dioxide are produced and 6 moles of water are produced when 1 mole of glucose is reacted. So see, 1 mole of glucose is producing 12 moles of a gas. That's what we get it from the balanced equation. Is it clear, Bani? Yes, can anyone calculate the answer? Okay, is it 0.0174 after 4? There is any other digit, Shrek? So it's 0.01745 and then it is going to be 0.175. Thank you, Shri. So it's 0.0175 meter cube will be the volume of the gas. Is this clear to all of you? Okay. Now in E part, the structure of glucose is shown in figure 3.2. The table 3.1 Identify the number of primary, secondary, and tertiary alcohol groups present in the structure shown in figure 3.2. Okay, we have to complete the table 3.1. Okay, so if you look at this one, isn't it? It's a primary. Now, 1, 2, 3, 4. If you look at all of them, they all are secondary, right? And there is no tertiary alcohol in it, because the tertiary is the one in which the OH bonded to a carbon, that carbon must be bonded to three different carbons. So that's nothing like this in the whole structure. This one is a primary. There are four secondary. This one, this one, this one, this one, all of them are secondary, because these carbons are bonded to two more carbons, not three carbons. Okay. And there is a no tertiary over here. Is this clear? And beside this, we have a one ketone. Oh, sorry, aldehyde in it. Yeah. Is this clear to all of you? Okay. Now part 2. Separate samples of aqueous glucose are tested with the reagents shown in table 3.2. Complete table 3.2 with the observation for each reaction. Write no reaction if applicable. Okay. With KMNO4, as there are secondary and the primary alcohols both undergo oxidation, right? So we know that there is a change in the color of the solution, that solution oxidation would occur, turns purple to colorless. Yes, Fatma. See, the condition would be if the carbon is bonded to an OH and is bonded to a one carbon, and on two sides there is a hydrogen, then it's a primary. Or if instead of this carbon there is a hydrogen, then still it's a primary. For a secondary, a carbon is bonded to an OH, is bonded to two carbons and one side hydrogen, that makes it secondary. And for the tertiary one, a carbon which is bonded to an OH is bonded to carbon on three sides. So there is no such carbon which have a OH bonded to carbons on three sides. See, all of them which I highlighted right now has two carbons on these carbons, right? So they all are secondary. And if you look at this one, this is bonded to one more carbon only. So this one is a primary. Is it clear? Okay. Now Fehling solution and warm. So if you see the Fehling solution, it's an aldehyde over here. So with the Fehling solution, red precipitates. We are going to observe the red precipitates, right? And now with alkaline iodine and warm. Okay. So with the alkaline iodine, either we know this structure would be present in the compound, or if it's an alcohol, that alcohol must have this structure. So if you see in the whole compound, there is not a single CH3, right? So it means neither this one nor this one is present. So it means that with it's a iodoform test, right? Alkaline iodine and warm. So we are going to write no reaction. Yeah, alkaline iodine is the reagent for the iodoform test. Okay. There are many structural isomers of C6H12O6 defined structural isomers. So we know the structural isomers same molecular formula, but different structure of the molecules. Or you can write different structural formula of the molecules. Is this clear to all of you? Okay. Now we have a question number 4. Compound C and D are alkenes with the same molecular formula C5H10. Give the systematic name of a compound D. So it's carbon 1, 2, 3, 4, right? We have started from the carbon from the chain where the functional group is closest. So the alkene is closest. So the third carbon has a branch of one carbon. So it is going to be 3-methyl bute 1-ene. Is this clear? Explain why C and D do not show geometrical isomerism. Okay, because if you see this carbon has bonded to 2 hydrogens, and if you see this carbon is bonded to CH3 and CH3. So in both C and D, one of the double bonded carbon has two identical groups, and that is the condition that there must be a double bond, and each double bonded carbon must has two different groups. So here this double bonded carbon has two same groups, so that's why D would not show cis and trans. And this double bonded carbon has two same groups on both sides, it's bonded to CH3, so again it is not going to show cis trans. Is this understandable to all of you? Okay, now what they are saying, draw the structure of a molecule that is a positional isomer of C and D. Okay, so you have to change the position. Okay, now if you see this, the double bond is over here. What if I'll do? I'll keep the structure like this and see the position of a double bond here. Over it is here, it is over here. So if I put a double bond over here, so it would be a different position, right? So it would become a positional isomer. Okay, now part 4. Give the structural formula of compound found when D reacts with the hydrogen in the presence of platinum catalyst. So it's a reduction, it's a hydrogenation. So if you recall, D is C5H10. So a hydrogenation would occur and a double bond would be broken down and a alkane would form from the alkene. So it is going to be C5H12. So they are asking you the structural formula. So see over here, it's a D, right? So it would turn into this. So the structural formula would be this, that CH3. There are two CH3 which is bonded to CH and then CH2 and then CH3. So that is the structural formula. Don't make the molecular formula over here because they have asked you to write the structural formula. Is this clear? Yes, if anyone of you has any confusion, please ask. Okay. Now, C can form an addition polymer. Draw the structure of one repeat unit of our addition polymer. Okay. What is C? If you see, C is this, right? So if I make the carbons having a double bond, it would be like this. The carbon which is on the left of the double bond has two CH3 groups, and the carbon which is on the right of the double bond has a one CH3 group. And over here hydrogen. They ask you to draw the structure of a one repeat unit of this addition polymer. So the repeat unit must have a single bond. You have to make the empty bonds on both the sides. That's it. Now you got the one repeat unit of the addition polymer. Is this clear? You're still here if any? No, there is no need of a bracket over here. But you have to make the empty bonds on both the sides. Okay. Just give me a minute. Now, B part, the mass spectrum of C shows a molecular ion peak at 70. So obviously this is going to be its MR. This peak has a relative intensity of 48.7. Okay. The relative intensity of M plus 1 peak is 2.7. Show that this information is consistent with the molecular formula of C. So by the help of this, we have to find the number of carbon atoms to show that, if you recall, C is C5H10. So we have to justify this thing. We got the MR, and now we have to find the number of carbon atoms. So if you recall the formula for the number of carbon atom, it is 100 upon 1.1 times abundance of M plus 1 peak, or the intensity of M plus 1 peak over intensity of a M peak. So 100 upon 1.1 times 2.7 over 48.7. Can anyone calculate it and tell me the answer, please? It is the relative abundance of a carbon-13 and a carbon-12 homer, that in the whole sample of it's 100%, and in that whole sample the carbon-13 is 1.1%. So that's why we use it. Okay, Shrey. So see, it's 5.04. So isn't it equivalent to 5? So we got the number of carbon atoms which are 5. Now we have to justify the MR. We are getting this. We are getting 70. So we have to calculate the MR. There are 5 carbon atoms. So 12 times 5 plus there are 10 hydrogen atoms. So 1 times 10. So it will help me to get 70 over here. So the MR is justified with this one, and the number of carbon atoms are also justified. Is this clear to all of you? So this information is consistent with the molecular formula. Is this clear to all of you till here? Okay. Now, compound C and D both react with hydrogen bromide. C react with hydrogen bromide to form E. Okay. Complete the diagram in figure 4.1 to show the mechanism for this reaction. Draw a structure of the organic intermediate. Include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. So if you see, this is going to be partial positive and this is going to be partial negative. And from here, the attack is always towards the partial positive, right? So the attack would be taking place over here and the bond would be breaking like this. And if you see, the bromine is bonded to this carbon, which is on the left of the double bond. So when I'm going to make the intermediate, I'm going to put the hydrogen over here and make this carbon positive charge and put the bromide ion over here with the lone pair. Now, over here, from the lone pair, it attacks this positively charged carbon and then E would form. Is this clear to all of you? This would actually help me to identify that where the hydrogen is going to bond. See, there are 2 carbons only, and over here we are getting the bromine. So it means when this double bond attacks, it bonds with the hydrogen, so that hydrogen is going to bond over here on that carbon, and then the bromide ion would attack on this carbon. Is this clear? Okay. Now, D reacts with hydrogen bromide to produce F, a chiral bromoalkane. Draw the structure of F. Okay, if you recall, D, D is this thing. And they have told you it has a chiral structure. So when it reacts with the HBr, a bromine is going to bond over here and hydrogen gets bond over here, right? So if you see, this carbon becomes a chiral carbon. On one side there is a CH3, on the other side it's bromine, and on the third side we got a hydrogen, and on the fourth side we have another alkyl chain. So this would be the structure of F. Is this clear? Now, third part, explain why the reaction of HBr with C and D produces different major products. If you see, in C, if you see, we got this as a carbocation, right? Because hydrogen bonded over, hydrogen bonded over here. And if you look over here, hydrogen bonded over here, and this carbon becomes a carbocation. It is because, see, here the bromine got bonded, right? So it's clearly identifiable here. It's a tertiary carbocation which is made because the carbon which becomes positive has a 3 more carbons. And in D, a secondary carbocation has been made, right? And if the other one becomes the carbocation, then in this case it's secondary, and in this case it is going to be primary. Okay, so we are going to explain it in on the same basis that in C, a tertiary and secondary carbocations are formed, and in D, a secondary and primary carbocations are formed. Is this clear? And further we know, more alkyl groups causes greater positive inductive effect and produces more stable intermediate carbocation. Just give me a minute, please. So in C, tertiary is more stable than secondary, and in D, secondary is more stable than primary. Is this clear to all of you? Okay. C can be used to form H. Okay. C was this one. One possible synthesis of H is shown in figure 4.5. Okay. Different portions of C are used in reaction 1 and 3. Some of the products are then combined to produce H. Okay. Figure 4.5 does not show any of the inorganic products of the reaction. Okay. Complete table 4.1 with the reagents and conditions required for each of the reaction in figure 4.1. Okay. From C to E, it's HBr and it's a reaction 1. Okay. Yeah. If you see H, see, it's very important. If you see H, isn't it? It's an ester. And that ester is actually made from this carboxylic acid and this alcohol. So, if you look at E, it can easily help me to identify that J would be this. And if J would be an alcohol, then here aqueous sodium hydroxide is used with heating. So in reaction 2, I have identified the reagent and condition that aqueous sodium hydroxide is used and heat or warm. Is this clear to all of you? Yes. Now, so, and further, if you look at H, it means if you see over here that this part comes from J, so it means the rest of the part comes from G. So it means G must be C double bond OOH, right? And if C, a alkene is turning into ketone and a carboxylic acid like this, it means it is going to be broken down into this one. This part is turning into ketone and this part is turning into carboxylic acid. So it clearly indicates that here hot, concentrated, acidified potassium magnate has been used. Is this understandable? Yes. So hot, concentrated, acidified KMnO4 is used. Now G plus J reacts with H. So if you recall, for this reaction, it's an acidification. We need a sulfuric acid as a catalyst and heating, right? We use concentrated sulfuric acid and heat. So concentrated sulfuric acid and heating or warming. Is this clear to all of you? So here we have ended the paper. And okay, tomorrow I'm going to keep a one paper session for a practical paper 3 calculations, workings, and the errors. It is because you know that after the tomorrow there is a practical exam for most of the students, right? They are giving P 3. So tomorrow I will be keeping that session. Okay. Okay, then see you everyone tomorrow. Take care. Allah Hafiz. Goodbye.